Hello, grade 9 students. So today we'll be reviewing for your quiz 1 term 2. So let me start by reviewing the work. The work, if the displacement is in the same direction of the force, then the work is F times D, and the work is positive. If the displacement is opposite to the force, then the work is minus F times D and it's negative. If the displacement is perpendicular to the force, then the work is 0, and the reason is perpendicular. Now, another thing that I want to mention, which is very important, the formula of the kinetic energy is half mv square. So we say that the kinetic energy is proportional to the mass, and the kinetic energy is proportional to the square of the speed. And let me wrap up, or let me also add that the formula, okay, for the kinetic energy is half mv square. The change in the kinetic energy is kinetic energy final minus kinetic energy initial. Okay. Now also let me state the following, that so now we are in idea, which idea? Idea 4. So idea 4 would be if the kinetic energy is half mv square, the triangle would be the double of the kinetic energy, m and v square. So suppose that we have the mass is equal to 20 kg, and the kinetic energy is given by 2500 joules, then how can we find the speed? Remember that first we need to find v square, which is the double of ke, divided by m, and that would be the double of 22,500 divided by the mass, which is 20. That would be 5,000 divided by 20, which is how much? Let me do it. 5,000 divided by 20, which is 250. And remember that here we don't place the unit, so if v square is 250, then v would be given by the radical of 250, or the square root. And doing that on the calculator, the value of the speed would be given by 15.8 meter per second. And finally, I want to review with you guys the following. So suppose we have the following graph. So this is F and this is D, and we have a straight line like that. And let me say this is 4 meters, and this is 10 newtons. So how can we find the work? The work would be the area. So how do we do the area? This is a triangle. So the area would be base times height over 2. This is very important. The base is 4, the height is 10 over 2, and that would be 20 J4 joules. Okay, so this is very important. And now let me solve the following exercise. They're telling us a box of mass 3 kg, so the mass is 3 kg, and the force is 20 newtons to the right, so we have a force of 20 newtons to the right across a rope. So a box of mass 3 kg is pushed by a force F is equal to 20 newtons to the right for a distance d is equal to 12 meters. The pushing forces along the rope is opposed by frictional forces 9 newtons. So this is 20 newtons along the rope, and this is 9 newtons of friction because the surface is rough. Alright, so in part A we need to list the forces acting on the block. Because we have a mass, then we will have the pull of gravity, which is Fg. Because we have a table or a support, we will have the normal push given by Fn. We have the force capital F, force on the rope, and we have a friction, which is Ff. Now in part B we need to draw an FPD of the box. So this is the dot. We would have the force of gravity down. We would have the normal push, which is up. We have the capital F to the right and the friction to the left. So this is the normal push. That would be the pull of gravity. That would be the capital F, and that would be the friction force. Now in part C, they're asking you to calculate the work done by the rope. So by which force? Is it gravity Fn or capital F or Ff? So they're asking us for the rope. The rope is this one. So notice that the displacement is to the right. This should be given, the displacement d. So both capital F and d, they are in the same direction. We will use that W is F times d, which is 20 times 12. And doing that on the calculator, that would be 240 joules. Now in part D, they're asking you to calculate the work done by friction. It would be minus Ff times d. Why? Because friction is to the left and it's 9. To the left to the displacement is to the right, and the distance is 12. So doing that on the calculator, that would be minus 9 times 12, that would be minus 180 joules. And finally, in part E, they're asking you to calculate the net work done by all the forces. So W net would be the work done by gravity, plus the work done by the normal push, plus the work done by capital F, plus the work done by friction. Now the work done by gravity is 0, and the work done by the normal push is 0 because the displacement is to the right. So gravity is down, displacement is right, that would be 0. Normal push is up, displacement is to the right, that would be 0. So we just add 240 and minus 108. Putting that on the calculator, that would be 132 joules. And that's it for me in this video, guys. See you soon in a new one.